This is the first part of the notes on section 12.3 on limiting reagents and percent yield. Needing an excess reagents, the limiting reagent gets completely used up in a chemical reaction, and the limiting reagent determines how much product will be formed. The excess reagent is not completely used up, so there will be some of that left over when the reaction is all done. The first example we'll look at, we have our balanced equation up here. And the problem says if 4 grams of hydrogen are reacted with 85 grams of chlorine, which one will be the limiting reagent? Reagent, by the way, is just another term for reactant. So they're items that we're starting with, things on the left side of the arrow. In this type of problem, you're going to be given the amount of each reactant. So we have 4 grams of hydrogen, that's this reactant right here, and we have 85 grams of chlorine, that's this reactant right here. Now, what we have to do is pick either one of these reactants and go 3-step mass to mass to figure out the mass of the other reactant that we need. It doesn't matter which reactant that you pick. I'm going to pick the 4 grams of hydrogen, and I'm going to go with 3 steps to figure out grams of chlorine that are needed to react with that. This is what that calculation looks like. You start with the 4 grams of hydrogen. Molar mass of hydrogen, here's the mole ratio, it's 1:1, and there's the molar mass of Cl2. So, and our answer is 142 grams of Cl2. Okay. Now what you have to do is think about what this means. This means that the 4 grams of hydrogen needs 142 grams of chlorine to react. Now you compare that to what you actually have, which is given in the problem. We have 85 grams of chlorine to work with. So we need 142 grams of chlorine, but we only have 85 grams of chlorine. So that means that chlorine is our limiting reactant. So we just want to indicate that. You want to do the math to show how much is needed. Then you also want to indicate in the problem what is the limiting reactant. You can do it just like this. Now with this you can also say that hydrogen will be in excess. So H2 is in excess. So here's another example. You have another balanced equation up here, and the problem says if 48.6 grams of magnesium are reacted with 48 grams of oxygen, which one will be the limiting reagent? So again, we have the mass of magnesium, we have the mass of oxygen. Those are both given in the problem. We have to pick one of those and convert 3-step mass to mass to the other one, and then we have to make a comparison. I'm just going to pick the 48.6 grams of magnesium and then go 3 steps to get grams of oxygen that are needed, and then I can make the comparison from that. This is what that 3-step calculation looks like. That's the mass that was given. 24.3 is the molar mass of magnesium, mole ratio, and then the molar mass of O2 right there. So what we find is that we need 32 grams right there. Okay, so the 48.6 grams of magnesium needs 32 grams of oxygen to completely react. Now you compare that to what we have given in the problem. There's 48 grams of oxygen that we have available. So we need 32 grams, but we have 48 grams, so we have plenty of oxygen. So oxygen is going to be in excess. That means magnesium is the limiting reactant. So again, the 48.6 grams of magnesium needs 32 grams of oxygen, but you have extra oxygen, you have 48 grams available, so you have more than enough. So oxygen is in excess, magnesium is the limiting reactant. This now is an extension of that same problem. So we still have the same amounts of magnesium and oxygen. So the question is how much magnesium oxide would be produced? So now we want to find how much product do we get out of the deal. Well, the key on this is you need to start with the limiting reactant. So on the previous problem we found that 48.6 grams of magnesium, that's your limiting reactant. That has to be the starting point to figure out how many grams of product you get. You can't use 48 grams of oxygen because that was in excess. Not all of that will react. So again, the key is you need to start with the amount of the limiting reactant that you have given in the problem. So we're going to start with 48.6 grams, and then you go 3-step mass to mass to find grams of magnesium oxide. And that calculation looks like this. So there's the 48.6 grams, molar mass, mole ratio is 2 to 2 in this case. There's our coefficients, and that's the molar mass of MgO. And our answer is going to be this 80.6 grams of magnesium oxide. And that's the end of the notes for this part.